going to show how to find, how to test a hypothesis or test hypotheses about a population mean with a population standard deviation unknown. So we're given quite a bit of information we don't have to calculate from raw data for this problem. So I'm just going to start putting it up here and we'll get through it. First of all, our H naught is mu equals 105. Our H1 is mu does not equal 105. Now just seeing that, we already know that, well, let's talk about everything we already know. Since our population standard deviation is unknown, we know that it's going to use the t-tables. We're going to be using a test statistic t-tables. Put that up here now. T-tables. And since we are comparing mu is 105 to mu is not 105, we know it's going to be a two-tailed test. So we're given n is 35. That's our number of pieces of data for the sample. Our sample mean, or x bar, is 101.9. Our sample standard deviation, not our population standard deviation, sample, S sub x is 5.9. Our alpha value is 0.01. Now to find critical value you will need to determine whether your test statistic T is in the rejection region or not. To find that, you will use the t-tables in your textbook in the back or online, either way. So the t-tables have numbers across the top, numbers across the left column. The left column are your degrees of freedom. Degrees of freedom is always going to be n minus 1. N is 35, minus 1, 34, so find 34 on the left side. And our alpha is 0.01. Now because this is a two-tailed test, we need to split that. We want equal tail on the left compared to the right. So 0.005 on the top, 34 on the left, brings you to 2.78. Now it's not just 2.78, it's plus or minus 2.78. So plus or minus 2.78. Now the formula for finding T, I'm going to write this up and then I'm going to erase it, so copy it down or rewind, whatever. So T naught is going to equal x bar minus mu over S sub x over square root of n. So if you're doing this on the calculator, which I hope you are because nobody wants to do this by hand, make sure you have your parentheses right. If your syntax is wrong, your answers are going to be wrong. And I'll show you how to check your syntax with the TI-83. So you want parentheses here and parentheses here with your division symbol in between. Make sure you close the syntax when you open a square root. Hopefully you're familiar with all this. So that gives us our t-value. So test statistic T naught equals negative 3.1084. I'm going to round, that's already rounded. I'm going to round it even more to save myself some space. So negative 3. We'll say 11. It's not going to matter in this case. So that's your equation. I'm going to erase that now. The other way to check that, to make sure that you've done your math right, you always want to check where you can, is go under Stat. This is in the TI-83 Plus is what I'm using. I believe it's the same for the TI-83 and the TI-84. You go Stat, the Stat button, then you're going to scroll to the right to Tests, and then you're going to scroll down to T-Test. And you're going to enter your information. Your mu naught is 105, N 35, X bar 109, or sorry, 101.9, and your S sub X is 5.9. You do not need to put your alpha in there. That's for drawing the curve. I'm going to show you that next. Go down to the bottom and hit calculate. Before I forget, when you first open that sub menu and you can put all this data in, or all these are the statistics, not the data, I'm sorry. You can choose between data and statistics on top. This is a statistic entry. A data entry would be using your list with raw numbers. It's a lot more trouble, more time consuming, not really more trouble. Anyway, make sure you have all that right, and you should come up with the same number. Well, you're not going to come up with that exactly, but you should be able to round to negative 3.11. It's also going to give you a p-value of 0.0038. .0038. Now we can already make our decision and our conclusion just from these numbers, without our graph, and without drawing our curve. And the way we can do that is our critical value, plus or minus 2.78. So anything over or under, anything over positive 2.78, anything under negative 2.78 will fall into the critical value, which will reject H naught, and our test statistic is negative 3.11, so we know that that is less than negative 2.78, so we will be rejecting H naught. Also, your fail-safe is your p-value. P-value compared to alpha, if p, not probability, p-value is less than alpha, we reject. P-value is greater than alpha, we fail to reject. So you always want to make sure that not only is this correlation, this correlation between the critical value and the test statistic needs to be the same as the correlation between alpha and p. If you have a discrepancy, you need to go back and recalculate. You've made a mistake somewhere. Now then, we'll draw our curve. We always pretend that my drawings are symmetrical when they're supposed to be. Now when we get to chi-square, we don't pretend they're symmetrical, but we'll get there. So, look at that. That's nice, isn't it? Okay, so we have our critical values on the right and left. We'll shade those. Now this one, remember we have the plus and minus. So just like any number line, your minus is on your left, your positive is on your right. This is our artificial 0, which is actually 105 in this case, but represented by the mean 0. And critical value to the left is negative 2.78, positive 2.78. We know that because t-table refers to a symmetrical a symmetrical curve. Z-table as well. When you get into chi-table or chi-square, it doesn't work that way. It's a little more difficult to figure out your critical values. Where are we? Test statistic T. We need to graph this. Negative 3.11. That would fall to the left of negative 2.78. That would be probably a little further, but that will suffice. So that is T naught equal negative 3.11. That's in the reject region. Another thing to remember, I like to label our alpha is 0.01, so I'll label this area. Alpha refers to an area. 1% of the curve lies outside of 2.78, negative 2.78. So this is 0.005. This area refers to 0.005 of the curve. So our decision, I have trouble spelling decision sometimes. Decision, since T fell in the rejection region, the shaded area, we are going to reject H sub 0 or H naught or null hypothesis. Now by rejecting H naught, we have therefore strengthened our claim. Remember, this was the claim. That was a given. I'm not sure if I stated that. That was a claim. Always make sure you know which hypothesis is your claim. So, the conclusion is that there is sufficient evidence to support the claim. That's it. I think it looks good. Hope it made sense.